Hello. In this video we are going to talk about CISC and RISC computer. So first we want to know what is a processor. Processor is just another term for the CPU. CPU is central processing unit, and the primary functions include fetching, decoding, executing, and the write back function. There are two types of systems: the complex instruction set computer and the reduced instruction set computer. CISC and RISC are the types of microprocessor architectures. So let us see the difference between CISC and RISC. In complex instruction set computer, there are large number of instructions, and in reduced instruction set computer, there are few instructions. So what does this mean? This means that we have multiple instructions which are easier to debug, but in reduced instruction set computer only essential instructions are there. Some instructions that perform specialized tasks and are used infrequently. This means suppose we want to test a single bit, it is possible in CISC microprocessor, and in RISC computer there are few addressing modes. In CISC it is a large number of addressing modes. So suppose we have 5 to maybe 15 number of addressing modes in CISC computer. In a reduced instruction set computer we have only 3 or 4 addressing modes. So only 2 bits are required to tell which mode the computer is working in. In CISC there is a variable length instruction format. So my 1 word instruction, 2 word instruction, or 3 word instruction, all are possible. 1 word, 2 word, and 3 word, all are possible in CISC computer. I want to mention here, because of large number of addressing modes, the size of instruction increases. Obviously for 3 or 4 addressing modes only 2 bits were required, but for 15 addressing modes the 4 bits will be needed to specify just which mode the computer is working in. So the size increases. Now because of the size, my overhead of the program increases, and the program can be translated faster, so compilation becomes easy. Compilation is easy for this. When instructions can manipulate operands in the memory, it is possible in CISC only. So we can directly manipulate my operand in the memory. So this memory location can be directly manipulated by using the CISC instruction. Whereas in the RISC system we cannot directly access the memory. We have only load and store, so we can only load or store the instruction. If I want to update something in the memory, then that thing has to be loaded into the register. That value has to come into the register. Then we can manipulate the value of the register. After updation we can send this register back to the memory location. Now because in the CISC format we can manipulate directly the memory operand, so my instruction will not be single cycle. I have to go to that memory location, I have to decode that value, and then I have to update it. After updating I have to come back to the original program. So there will be multiple clock cycles to handle one instruction of CISC computer, but in RISC system only single cycle instruction is possible. CISC is programmer oriented and reduced instruction set computer is machine oriented. The instruction in RISC is fixed length, so it is easily decoded. Why? Suppose I have a RISC instruction which is 8-bit long. So I can bring this 8-bit into the CPU, and this instruction can be decoded and operation can be performed easily. Every time something I want to fetch, it is of 8-bit only. So this is faster decoding. Reduced instruction set computer, it is hardwired rather than microprogrammed. Why? Because of fixed length and all the instructions to be able to be solved in single cycle, we can directly build the hardware which can perform this operation as it is, other operation as it is. So it is hardwired and it is hardware oriented rather than the microprogram control. Example of RISC computer program can be seen below. So I want to do the operation x equal to a plus b into c plus d. Initially we have to load all the values of a, b, c and d in 4 different registers. So a is loaded in R1, b is loaded in R2, c is loaded in R3, d is loaded in R4. Now we want to add a plus b and we want to add c plus d. Now after the loading, what we want to do? We want to do a plus b. So we can add R1 and R2 and save the result in R1 itself. Then we want to do c plus d. So it can be done by adding of R3 and R4. So add R3, this should be R4. So R3 and R4 are added and the result is kept in R3. Now we want to multiply the results. So this was saved in a plus b was saved in R1, c plus d was saved in R3. So we can multiply R1 and R3 and save the result in R1, and finally we can save this final answer into the x location. So this is x. So this is how we can run the program using the RISC set of instructions. This should be R4. Now I want to show the comparison for multiplication. So if I want to do the multiplication using the RISC instructions, what I have to do? I have to put some value in R1, suppose 5h. Then I have to put value in R2, suppose 2h, and I have to do the product of R1 and R2, and the final answer, which is calculated after the product, is stored. So for multiplication we are using 4 instructions, but for multiplication I can just do R1 and R2 multiplication in a single command and the result will be saved in R1. Patterson said, the simplicity of the instruction set and the addressing modes allow most instructions to execute in a single machine cycle. So more the simple the instruction set and the addressing modes are, the instruction can be executed in a single machine cycle, and the simplicity of each instruction guarantees a short cycle time. In addition, such a machine should have a much shorter design time. Obviously, if my work is needing short cycle time, my hardware will be also less. So the fundamental difference between the CISC and RISC is, RISC does not do direct operation on memory. Only load and store instructions access memory in RISC. The rest operate between the registers. Every other operation is done between the registers. This restriction simplifies the design. So we are restricting the functionality by only giving load and store instruction the access of memory. All the other instructions have to work through registers, and because of this restriction the design is very simple. Examples of CISC processors. So x86 uses the CISC processor, and Intel is now using microcode, which is a lower level machine code, to take advantage of the RISC pipeline efficiencies. So in CISC processors also, this Intel, what it is doing now, they are using within the CISC, they are breaking down their instruction into the RISC instructions, and internally the working is done using the RISC architecture, but overall they are interpreting the instruction as the CISC instruction. So the CISC architecture is used in low-end applications such as security systems, home automation, etc. And the example of RISC processors are, it was used in MacBook 1998 to 2005 in the form of PowerPC. Also this ARM processing. What is ARM? ARM means Advanced RISC Machine. So the ARM processors are being used in the Apple AI chips in the iPhones, and also IBM's Watson is using the ARM processor, which is based on RISC processing, and it is very efficient for the mobile devices. All the Android phones are also using RISC processing. So RISC architecture is used in video processing, telecommunications, and the image processing. Thank you for watching.